Section 11.3, Introduction to Polynomials. In this video, we are going to define a polynomial and learn how to classify various types of polynomials, and we're also going to learn how to evaluate polynomials for given values. So the first thing we need to do is go over some definitions and terminology that we're going to use. First of all, we'll discuss what do we mean by a monomial in X. If we have a monomial in X, it first of all looks like the form k times x to the n, where k is going to be a real number and n has to be a whole number. We call n the degree of the term and k is the coefficient. So as an example, if I had 2x to the fourth, the 2 is the coefficient. It's always going to be the number that's being multiplied by the variable. And the 4 is the degree. So we would say this is a fourth degree polynomial or monomial. Now, if we have a polynomial, it is either a monomial or a sum and difference of monomials. We can also talk about the degree of a polynomial by just looking at the degree of all the different terms. And we take the largest of those. And then we also talk about the leading coefficient of a polynomial, and that is the coefficient in front of the largest degree of your variable. So let's look at what we're talking about. So first of all, a polynomial might be something like this: 5x to the fourth plus 3x squared plus 2x minus 1. Each one of those satisfies the condition to be a monomial, because we can imagine this as being x to the 0. And we're adding or subtracting those different monomials together to form a new polynomial. Now, each one of those terms has a degree. So if we look at this first term, 5x to the fourth, the degree is 4. The second term is a second degree term, first degree, and then 0 degree. So the degree of the entire polynomial would be the fourth degree, because that's the highest degree of all the terms. And then the leading coefficient is the coefficient of your highest degree term. So since x to the fourth is my highest degree, then 5 would be the leading coefficient. Now we do need to talk about things that wouldn't be a polynomial. So let's look at an example of something that's not a polynomial and why it's not. So if I had something like 4x to the negative 2 plus 3, that's not a polynomial, because to be a monomial, remember that our exponent has to be a whole number. So that's not a whole number, because whole numbers are the numbers 0, 1, 2, 3. So no negative numbers and no fractions or decimals. And since this is a negative number, then that can't be a monomial, and so we can't have a polynomial. Now we also have special names or terms we use for various types of polynomials. So if our polynomial only has one term, it's called a monomial. The prefix mono means one. Here are some examples of monomials. So again, let's look at this last one. We would say that that's a fifth degree monomial with a coefficient of 4. If your polynomial has two terms, it's called a binomial. So those would look like 3x plus 5 or a squared plus 3. And then trinomial has 3 terms. So I might look at, let's say, this last example. We would call that a trinomial because it's 3 terms. We would say it's a third degree trinomial because the highest exponent in there is a 3, and the coefficient or leading coefficient would be a 1, because remember, it's understood that if a variable doesn't have a number in front of it, that there's a 1 there. So our leading coefficient would be 1. Now we're going to spend some time simplifying polynomials. We're going to simplify by combining like terms. We're going to make sure we put it in descending order. We're going to state our degree and the type of polynomial. So if I look at the first example, 5x cubed and 7x cubed are like terms, So they could go together and give me 12x cubed. So we've got it in descending order since we just have the one term. This would be a monomial because there is only one term. And its degree would be 3. In the second example, we've got a 5x cubed and a 7x cubed. So that's going to give me 12x cubed minus 2x. Since there are two terms, this is a binomial, and its degree would be 3 because that's the highest degree in the entire problem. In our next example, we have some like terms we can combine with our y and our 3y, but since we're putting in descending order, let's start with our highest power first, which would be negative 2/3 y squared. Then combine 1/2 y plus 3y, which would be 3.5 y, or 7/2 y, and then minus 7. This has 3 terms to it, so it's a trinomial. And the highest degree of the problem is 2, so the degree of the polynomial is 2. In our next example, notice that if we start combining like terms, a positive x squared and a negative x squared will cancel, and then we'll have 8x minus 15, which can't be combined, and then that is a binomial, and it is a first degree binomial because our exponent, our highest exponent, is 1. And then in our last example, that is not a polynomial, and that is because of the last exponent. Notice that we have an exponent of -1, and polynomials can't have exponents that are negative. So let's combine like terms with this example. We have x squared and negative 3x squared, and we're going to put this in decreasing order, which is very standard for polynomials. So that would be negative 2x squared. Then I have a 7x and a negative 3x, so that's going to be plus 4x because positive 7 minus 3 would be 4, and then plus 6. This is a trinomial because it has 3 terms, and the degree will be 2 because our highest power in our monomials is 2. Now we're going to look at how to evaluate polynomials. So say that we've been given this notation that p of x, and that this is just a way to signify what equation you're going to look at. That's called function notation. So if p of x is 4x squared plus 5x minus 15, we want to find p of 3. Well, to find p of 3, what I want to do is I am replacing all my x's with a 3. That's all that means. So we're going to go back now and take our equation, and we'll substitute in 3 for all the x's. So I'm going to do 4 times 3 squared is 9, so 4 times 9 is 36, plus 5 times 3 is 15, and then minus 15. So if I add all that together, we get 36. So we're saying that p of 3 is 36. In the next example, we want to find p of -2. So we're going to replace all my y's with -2. So -2 cubed is -8, and 5 times -8 is -40, plus -2 squared is +4, plus -3 times -2 is +6, and then plus 8. So now if I take -40 plus 4 plus 6 plus 8, I'm going to get -22. Now let's look at a little different example. Let's say the f of x is 6x plus 13, but I want to find f of 2a plus 1. Well, just as before, if I had a constant there, I would replace x with whatever the constant was. I'm now going to replace x with 2a plus 1. So I'm just going to take my equation, and every time I see an x, I'm going to put in a 2a plus 1. And then we'll simplify. Now I can use distributive property. 6 times 2a would be 12a. 6 times 1 would be 6 plus 13. But then combining like terms, we get 12a, and then 6 and 13 would go together and give me plus 19. In our last example, we want to take the polynomial p of x and find p of 3. P of 3 would be 5 times 3 squared plus 6 times 3 minus 10. 3 squared is 9. 9 times 5 is 45 plus 18 minus 10. So now if I grab a calculator and add 45 and 18 and then subtract 10, I'm going to get 53.